All right, so number 14, here we're multiplying now, and we have coefficients right in front of the radical. We have values outside, and so all you do is just really intuitively just multiply whatever's outside with whatever's outside. So 3 times 4 is 12, and then I'm going to multiply whatever's inside together. What I usually do when I multiply values inside the radicals is, instead of multiplying them together and getting a larger number, what I do is I just kind of keep them separate as a product, and then I can break them down. And because remember, at some point we want to figure out what pairs there are, because it's a square root. And so instead of building a bigger number that I'm just gonna have to break down anyway, I'll just kind of keep it broken down, and that'll make it a little bit easier to get those other numbers. Okay, so I'm gonna put these together inside the radical, and I see that 12 is 2 times 6, which is 2 times 3. 20, you could do 2 times 10 or 4 times 5, right? Remember, it doesn't matter the order. And so we're looking for pairs, right? Sets of 2 for things that come out. So I have a set of 2 2s there, and then I have another set of 2 2s here, and then I have a 3 and a 5 that are left over. Okay, so I already have a 12 outside, and then 2 2s will come out, and then back on the inside is going to be 3 times 5, and you multiply them on the inside. So yeah, anything that comes out you multiply together, and anything that stays in you multiply together. And so 12 times 2 times 2 is going to be 48, and 3 times 5 is 15, so it'll be 48 root 15. All right, so that's how you multiply radicals, especially when you have stuff outside and inside. So 15, we're adding and subtracting radicals. So when adding and subtracting radicals, you can only combine like radical terms. So like radical terms have the same index and the same radicand. Let me just show you that definition. So like radical terms, or like radical expressions, have the same index. Both the index and the radicand are identical. Okay, so make sure that the index and the radicand are identical. Okay, so if you have something like this, the 5th root of 7 plus the 5th root of 7, that works, right? But what doesn't work is the cube root of 7 plus the 5th root of 7. Okay, that doesn't work. And what else doesn't work is the 5th root of let's say 11 plus the 5th root of 7. Okay, that does not work. All right, so anyway, so they have to have the same index and the same radicand at the same time. All right, so going back to here. Now, none of these all have the same index because they're all square roots, right? But none of them have the same radicand. So, but before you move on from this and just say that, well, we can't add or subtract these, you have to try to simplify each radical individually first, right? So let's take each of these individual radicals and see if we can find anything that comes out. Okay, so 48 is we can do 6 times 8, 2 times 3, 8 is 4 times 2, which is, and 4 is 2 times 2. So we have a pair of 2 here, a pair of 2s here, and another pair of 2s here, and then we have a leftover 3, right? Remember, we don't worry about these composite numbers, just the prime numbers. And so we already have a 2 outside, and so we're going to have, you don't have to show all this work, but we're going to have 2 times 2 times 2, right? There's 1 2 that was already there, and then there are 2 2s that came out. And so that'll be 8 on the outside, and then we'll have a 3 left on the inside, so it'll be 8 root 3. Okay, let's do the same thing with 75. So 75 here, we have a minus, right? So I'm just going to bring that down. And then 75 is 5 times 15. 15 is 3 times 5. So I have a pair of 5s, right? And then a leftover 3. So a 5 is going to come out, and then a 3 will stay inside. So I can already see that now we have like radical terms, right? Okay, and then 12 breaks down, so that'll be 3 times 4, and 4 is 2 times 2. So we have a pair of 2's come out and a leftover 3. So remember it's minus, so I'm going to bring down minus 2 and then root 3. So it turned out that we went from having no like radical terms to now they're all like radical terms, right? They all have the same radicand 3, and they all have the same index, which is 2. And so we can combine these together. And the way you combine them is just think if it were 8x minus 5x minus 2x. It's the same idea. You just combine the coefficients, and then the radical stays the same. So 8 minus 5 is 3. 3 minus 2 is 1. So we end up with 1 root 3. But that 1 will make invisible. Okay? So that's our answer after all that. Okay, so make sure you simplify each radical individually. And then whatever your like terms are, make sure you combine those radical like terms or radical like expressions. All right, now number 16. So number 16, now we have these binomials with radicals, right? So we have kind of binomial radical expressions, and we're multiplying them. So we would just FOIL just like we would, if these were variable expressions or whatever. Anytime we have a binomial times a binomial, we can use the FOIL method. So 3 times 5 is 15. 3 times root 2, it's just going to be 3 root 2. So when you multiply an integer times a radical, you just kind of tag them together, right? You can't mix them. You can't multiply inside. Yeah, they don't mix. They just kind of stick together. Same thing here, right? Negative root 7 times 5 is just going to be negative 5 root 7. All right, so radicals a lot of times behave kind of like variables where you just kind of tag them onto their coefficients. All right, and then here we have negative root 7 times root 2. So those are both radicals with the same indices, so we can multiply those together. So negative times a positive is a negative, and 7 times 2 is 14, so it just becomes root 14, right? So we're using that property where as long as the indices are the same, we can multiply these radicals together, right? So we multiply what's underneath and put them under the same radical. All right, so now we want to see, is there anything we can simplify? And not really, right? Like 2 and 7 are prime numbers, so we definitely can't bring any pairs out there. 14, just like we saw, is 7 times 2, so we can't bring anything out there. There are no pairs. And none of these are like radical terms. So this is actually our final answer. Can't do anything more with that. All right, so we saw one earlier where we had a bunch of like radical terms and we combine them. And then we see one here where we have no radical terms, no like radical terms, and we just have to leave it there. That's as simple as we can get, even though it doesn't seem simplified. That's as much as we can do with that one. All right, and then last but not least, let's take a look at 17. So 17, we have this binomial squared, right? This radical binomial squared. So all we do is just multiply it by itself, right? So let me tell you the temptation to resist here. A lot of people want to distribute the 2 here and just say, oh, it's going to be root 2 squared, which is 2, minus 6 squared, which is 6. So it'll just be 2 minus 6, negative 4, right? And you'll get that. Like that, those things will come out, but you're missing something that you'll see when we do this. So resist that temptation, okay? So it's not as simple as root 2 squared minus root 6 squared. That's not how it comes out, okay? All right. Let me erase that. But yeah, resist that temptation. We can do that if we were multiplying, then we can distribute the exponent. That is a rule that we've seen before, but it's when we're multiplying a bunch of stuff on the inside, not when we're adding and subtracting. All right, so here we go. So we're going to multiply root 2 times root 2, which is square root of 4. And square root of 4 equals 2, right? So remember, when we multiply a square root by itself, we just get the radicand. And so root 2 times root 2 is just 2. So then we have root 2 times negative root 6, which is negative root 12. And we can break that down, right? 2 times 6, 2 times 3, so we have a pair of 2's and a leftover 3, so it'll be 2 root 3. Okay? And then I'm going to multiply negative root 6 times root 2, so that's the same exact thing, right? It would be negative root 12, which we just talked about is negative 2 root 3. All right, so same thing here as here, same sign and everything. And then the last thing we'll multiply is negative root 6 times negative root 6, which is positive, and negative times negative is a positive, and we'll get just regular 6, right? Once again, the square root of 6 times the square root of 6 is square root of 36, and the square root of 36 is 6, right? So if we multiply a radical by itself, we get the radicand without the symbol. All right, so now we do have some like terms, right? Now we can combine these radicals together. We have like radical terms, and we also have like integers as well. So 2 plus 6 is 8, and then negative 2 root 3 minus 2 root 3 is going to be negative 4 root 3. And that's our final answer. We don't have any like terms from that point, so we just leave it like that. So if you would have done the 2 minus 6 thing, or even 2 plus 6 thing, that would have given you 8 maybe, but you would have missed out on these middle terms, okay? So make sure that you don't just distribute the exponent if you're adding and subtracting on the inside of the parentheses, okay? The power rule works when you're multiplying inside, when you're multiplying a bunch of things, but not when you're adding and subtracting.